acid-base titrations. This is the fifth video of this series. We are going to learn this lesson step by step through problems in this series of videos. There's a problem here. Let's discuss it. 70 milliliter of a 12M sodium hydroxide solution was used to neutralize 150 milliliter of an HCl solution. What's the molarity of the HCl solution? 70 milliliter of a 12M sodium hydroxide solution was used to neutralize 150 milliliter of an HCl solution. What's the molarity of the HCl solution? We know the volume of this sodium hydroxide solution 70 milliliters. For this titration we have used 70 milliliters and we know the molarity 12M. 12M. That means there are 12 moles of sodium hydroxide in 1 liter 1000 milliliter of this sodium hydroxide solution. Now we can find the number of moles in 70 milliliter of this sodium hydroxide solution. We know the volume and the molarity of the sodium hydroxide solution. Therefore, we can find the number of moles in sodium hydroxide solution. If we want, we can use formula of molarity M equals N divided by V. Otherwise, we can follow this method. Molarity 12M. That means in 1000 milliliter of the sodium hydroxide solution, there are 12 moles of sodium hydroxide. Therefore, in 70 milliliters of the sodium hydroxide, how many moles of sodium hydroxide are there? We can find the answer in this way. 12 mole NaOH divided by 1000 milliliter NaOH multiplied by 70 milliliter NaOH. 12 mole NaOH sodium hydroxide divided by 1000 milliliter sodium hydroxide multiplied by 70 milliliter sodium hydroxide. Units should be cancelled out. Milliliter NaOH, milliliter NaOH, then we get 0.84 moles of NaOH sodium hydroxide. In 70 milliliters of the sodium hydroxide solution, there are 0.84 moles of sodium hydroxide. This is the chemical equation. It's balanced. We can find the ratio. We can see the ratio to react with 1 mole of sodium hydroxide. 1 mole of HCl is required. To react with 1 mole of sodium hydroxide, 1 mole of HCl is required. Now we have 0.84 moles of NaOH. Therefore, to react with 0.84 moles of NaOH, how many moles of HCl are required? There's nothing to find. We can imagine. But this is the method. 1 mole HCl divided by 1 mole NaOH multiplied by 0.84 mole NaOH. 1 mole HCl divided by 1 mole NaOH multiplied by 0.84 mole NaOH. We should cancel out units. Mole NaOH, mole NaOH, we get the answer 0.84 mole HCl. We know the volume of HCl solution 150 milliliters. For this titration, we use 150 milliliters of HCl. In this 150 milliliters of HCl, there are 0.84 moles of HCl. There are 0.84 moles of HCl in 150 milliliters of this HCl solution. Now we have to find molarity of the HCl solution. Now we have to find the molarity of HCl solution. We can find the molarity moles per liters or moles per 1000 milliliters. In 150 milliliters of this HCl solution, there are 0.84 moles of HCl. Then, in 1000 milliliters of this HCl solution, how many moles of HCl are there? It is molarity. 0.84 moles HCl divided by 150 milliliters HCl multiplied by 1000 milliliters HCl. 0.84 mole HCl divided by 150 milliliters HCl multiplied by 1000 milliliters HCl. 0.84 moles HCl divided by 150 milliliters HCl multiplied by 1000 milliliters HCl. Unit should be cancelled out. Let's cancel out milliliter HCl, milliliter HCl. Now we have found our answer, molarity 5.4 m. What's the molarity of the HCl solution? 5.4 m. Thank you very much for watching this video. Please subscribe our channel. God bless you.